वही देखते हैं ये है क्या।
Hello guys, I am Saumarup Chakrabarti of Sardar Patel Institute of Technology, Mumbai. I am a second year EXTC student and today I'll be explaining you everything about a thermal camera. So these are the topics which we'll be going through in this video. We'll cover the introduction, the working, the block diagram, the applications of the thermal camera, its types, its advantages, disadvantages, and ultimately its conclusion. Basically, a thermal camera, also known as an infrared camera or a thermographic camera, is a device that captures and visualizes infrared radiation emitted by objects and surfaces and displays it on its screen, which is inside the camera. So it is different from a regular DSLR camera, and it is different in that way, in the sense that it focuses only on the infrared radiation, unlike DSLR cameras that only rely on the visible light. So, according to the infrared radiation, the different temperatures of different objects and bodies can be mapped out and they can be seen as different colors inside the thermal camera's screen. Also, we have put down some features and applications in short. So, the features include infrared detection, temperature measurement, PC connectivity, graphical display, and real time imaging. So, moving on. This is basically the anatomy of a thermal camera. As we can see, this is the working principle. So basically, the working principle is that the thermal camera works by detecting the infrared radiation emitted by objects. The infrared lens, which is present, focuses this radiation onto a thermal imaging sensor, which then converts it into electrical signals. Signal processing creates a temperature map displayed as a thermal image. Therefore, different colors or shades represent varying temperatures. The user interface of the thermal camera allows adjustments, and in the sense we can change the type we view the image, and the final image helps visualize temperature differences, making thermal cameras very valuable in case of applications like night vision, industrial inspections, and medical screenings. So basically, as you can see on the screen, these are the parts which a thermal camera consists of. So it consists of an infrared detector, optics, signal processing unit, image display, and a basically user interface screen, which we'll get into detail in the next slide. So now that we've understood the working principle of the thermal camera, let us now move on to the block diagram of the same. So basically, the first unit that is present is the lens. So what it does is that the incoming radiation from the scene is captured and focused by this unit. The quality of the optics is crucial because the better or the higher grade of the lens, the more accurately and the more amount of layers it can detect in different temperatures, so that when it displays the same, there are more layers, so more shades of the color would be represented. Moving on, the next part is the thermal imaging sensor or the filter. So basically, since the lens collects all sorts of radiation, so there should be a filter or a particular unit in which only the infrared radiation is isolated so that the thermal camera, which only works on infrared radiations, can further process it into its own digital signals. So that's what this unit is for. So moving on, we have the detector or the photo processing unit. So now that the infrared radiations are already present inside the thermal camera, now we have to make a unit which will convert the incoming light energy into electrical energy. So basically, the detector does that. It converts the infrared radiation's energy into an electric signal by using analog to digital converters. Moving on, we have the signal processing and amplifier unit. So this electrical signals or the digital data which is generated is now processed to create a thermal image. This means that different shades of colors are applied to different bodies depending on that various temperatures or the heat signatures they give off. This processed image is now sent to the real-time display unit. Now the image, which is now created by the signal processing unit, is now displayed on the camera screen through the display unit. This display unit can consist of more information such as the temperature of the body and also another type of display which is depending on the camera unit we take. And after that, this one is optional. We have a user interface in which the user itself can change the settings of the image which is produced. So basically, he can increase or decrease brightness, contrasts, and even color palettes. And according to that, the signal processing will modify and give those settings to the user. So moving on towards the applications. So the thermal camera has a lot of applications in real life day-to-day usage as well as in the industry. And one of its major areas where it is used is in the security and surveillance department. So basically, thermal cameras are used primarily during nighttime surveillance. Since if there are security cameras, which are CCTVs installed in a premises of a society or an industrial building for that purpose, during night, when all the lights are turned off, the CCTV, which relies on visible radiation as well, it cannot properly show an intruder or a robber walking into the society, right? So basically, that's where a thermal camera comes into the picture. It can generate the proper outline using the heat signatures of that person so that even when it is dark or even when there is no light present in the surroundings, using the heat signatures which is generated, we can easily identify that an intruder or an outsider has entered the building and therefore the higher authorities can be alerted with the same. Another application is in the search and rescue unit. Thermal cameras greatly help in search and rescue missions because they identify individuals stuck or trapped inside a particular place in low visibility conditions, such as dense forests or during nighttime operations. So, even if, and as I mentioned earlier, even if there is no light or very less light, the thermal camera can detect a person's proximity by using thermal imaging, and by giving off the heat signatures, the thermal camera can display a person's heat outline. So basically, it greatly helps in the search and rescue unit as well. Third, industrial inspections. So thermal cameras are also employed in industrial settings to identify the parts of a machine that are overheating and to detect electrical issues, short circuits, and other such electrical problems and perform predictive maintenance on various machinery in the industry. Thermal cameras are also used in the medical industry for medical imaging. So basically, these are used for contactless body temperature measurements, and as they are reliable and quick, so this is a great way of not wasting time and instantly various temperatures of a person's body can be easily stored inside a thermal camera. Also, it helps in rapid and non-invasive fever screening in various environments. Next, building inspections. Thermal cameras also help identify energy inefficiencies, insulation problems, and water damage during building inspections by visualizing the temperature variations. Moving on, firefighting. Thermal cameras are greatly used by firefighters to navigate through smoke filled environments. Since infrared radiations are of a higher wavelength, they do not deviate away and scatter when they encounter smoke-filled or smoke-filled environments. So basically, it can be used to locate hidden fire sources and to identify potential dangers during firefighting operations. So there are various types of thermal cameras. The four most used and broadly classified types are handheld thermal cameras, fixed mount thermal cameras, dual sensor cameras, and body temperature screening cameras. So, handheld thermal cameras, as the name would suggest, they are portable and easy to use thermal cameras designed for various applications which are not of an industrial level scale but of a day to day household level scale, like home inspections, outdoor activities, or in general troubleshooting. Now, coming to fixed mount thermal cameras, fixed mount or mounted thermal cameras are designed for continuous monitoring of specific areas. They're often integrated into surveillance system, and hence these are the types of cameras which are used in the security department. So coming on to dual sensor or day-night cameras. So basically these combine both thermal and visible light cameras in a single unit. So these cameras not only provide thermal imaging for detection of a person, and also they provide visible light imaging for particular identification of a person. So as you might have guessed already, these types of cameras are greatly used in perimeter security, search and rescue, and marine navigation operations. So last but not the least, we come to the body temperature screening cameras. So as the name would suggest, these cameras are specifically designed for measuring human body temperatures at a distance. These are also used for fever screening in crowded places. So as you all might remember, when the COVID-19 pandemic had hit us during 2020 and 2021, so basically body temperature screening cameras were greatly used to measure the temperature of a person by not maintaining contact with them. So at that time, the usage of these types of cameras had greatly spiked. These are also used in airport screenings, public transportation, and entrance checkpoints during health crises like COVID, which I had mentioned. So moving on to the advantages of a thermal camera. So why should we use a thermal camera? What are its advantages? You might be wondering. So basically, these are the advantages which I have broadly listed down. So basically, the first one is night vision. Since the thermal cameras can capture images in complete darkness as they detect heat rather than visible light, this makes them an ideal object for relying on surveillance and security applications during nighttime. Next, we have visibility through smoke or fog. Since thermal cameras detect on infrared light, which have a larger wavelength, they can penetrate smoke, fog, and other environmental obscurants, providing clear visibility in challenging conditions. This is particularly used in firefighting and military applications. We have non-contact temperature measurement. Like I mentioned earlier, thermal cameras allow us non-contact temperature measurement, allowing users to access the temperature of objects or surfaces remotely. This is useful in various fields, including medical industries, and research applications. Next, we have long range detection. Thermal cameras are capable of long range detection, allowing users to identify or monitor objects and people at a distance. This is beneficial for applications such as border surveillance, again, security, and large area monitoring. And this is possible because the infrared radiation which comes into the thermal camera is able to not deviate and scatter because of its large wavelength. So it is the intensity of the infrared radiation remains the same. Next, we have quick scanning and screening. Thermal cameras can rapidly scan and screen large areas for temperature variations, making them efficient for tasks such as fever screening in crowded places or identifying anomalies in industrial processes. Like I said, you can relate this application to the COVID-19 pandemic, where this feature was greatly used. Last but not the least, we have unaffected by glare or reflections. So thermal cameras are not affected by any type of glare, reflections, or direct sunlight even, which can impact the performance of traditional optical cameras since they tend out to lose their focus or produce distorted images with those in the picture. This makes them suitable even for outdoor and high glare environments as well, along with nighttime applications, of course. So coming to the disadvantages of a thermal camera. So first of all, there is a lack of detail in a thermal camera. Since the thermal cameras provide temperature information rather than detailed visual images of a person, they cannot be used for tasks that require high resolution imaging or the ability to distinguish fine details. Since using our heat signatures, we can only depict the outline of a person and not his entire visual features for the same. Next, the cost. So basically, good quality thermal cameras can be really expensive compared to traditional DSLR cameras. The cost, therefore, can be a limiting factor for some applications, especially in budget constrained scenarios. In India, a good quality thermal camera like the FLIR E6 costs about 2 to 3 lakh rupees, which is a great price for an average middle class person. Next, we move on to reflective surfaces. So, like I said, glares or normal reflections do not affect the temperature readings of the camera, right? But highly reflective surfaces, such as metals or glass, can in fact reflect infrared radiation, leading to inaccurate temperature readings and overall a reduced thermal image quality. Next, we have resolution constraints. The resolution of thermal cameras are definitely lower compared to visible light cameras. Thus, this can limit their ability to capture fine details, especially at longer distances. So, basically, less layers of temperature are detected when we move on to larger distances for temperature imaging. So, last but not the least, what do we conclude from a thermal camera? In conclusion, thermal cameras are a groundbreaking technology with diverse applications across various industries. The fact that they use infrared radiation provides unique advantages, including night vision, visibility to tough conditions, quick scanning, and non contact temperature measurement. Therefore, they are used invaluably in various fields such as security, medical fields, and even firefighting and search and rescue operations. However, it is essential to recognize the limitations of these thermal cameras as well, such as their lack of detailed visual information, which I mentioned earlier, their high cost, their sensitivity to reflective surfaces, and resolution constraints. Despite these drawbacks, understanding the capabilities of the thermal cameras is crucial for various applications, like I mentioned before. So, thank you for watching and have a great day.